Hello. Right, this video is all about bonding structure and properties using the exam technique approach. Please remember to subscribe and like this video and share this channel amongst your friends so it can continue to grow. I'm not going to read through the exam question approach because I've done that several times in many videos, but if you want to have a closer look, pause the video at this point so that you can read it. Right, so looking at question 1, we can see this question is about substances with covalent bonding, and straight away I'm thinking shared electrons. So one of the key things about the exam technique approach is to read and annotate as you go along so that you're picking up any of the clues, you're highlighting these things. Part A says the diagram below shows a ball and stick model of a water molecule. Okay, so it's a model. So that means it's not the actual thing, it's a way for us to understand how something we cannot see actually works. So I've immediately labeled the atoms in the model, in the diagram, and then it says suggest one limitation of using a ball and stick model for a water molecule. So this is basic recall of some facts about models and using models in science. And the first thing that pops to mind is it's not to scale. There are other things such as it doesn't show the flexibility of the bonds. It doesn't necessarily show how the electrons are in the model. It shows the electrons are fixed, but actually the electrons we know are moving around a lot more. So there's lots of limitations, and you've just got to remember those key limitations of using models in some of the different aspects of chemistry and physics. Part B. Ice has a low melting point, so obviously ice is frozen water, so I've just made a note of that. Water molecules in ice are held together by intermolecular forces. So these are the forces between the molecules. Now, water is a simple covalent substance, and that means that those intermolecular forces are weak. So I've made a note of that. Complete the sentence. Ice has a low melting point because the intermolecular forces are weak. That's what I was thinking of. And when I've checked the mark scheme, I've got those both right. Now that's a 2-mark question. And given that I've checking my recording, I've now been talking for 2 minutes 29 seconds. So obviously with the bit of the blurb at the beginning, when I introduced the video and me reading and annotating and answering the question, that was well within 2 minutes. Now part C. The image below shows the structure of a molecule, and they've labeled the oxygen atom, the hydrogen atom, and the carbon atom. So I can clearly see the carbon atom in the black and white picture is black, or a very dark color. And so I've labeled it clearly. And then they've shown the white colored atoms in the model as hydrogen. So I've labeled all of them as hydrogen, so it's clear for me to see. And the one in the middle, I know it's red, but it's the color that's not white, it's not black, is the oxygen atom. So I've actually written the symbols on the atoms. So now it says, what is the molecular formula of the molecule in the above image? It's really easy for me to see. I can see there's 1 carbon. I can see there are 4 hydrogens and 1 atom. So I just write that down. And I have to remember that when I'm writing the number of atoms, the number has to be subscript. So that means lower number, a number by the bottom of the line. Superscript means a number that's above. So when I'm writing charges, for example, I would write a superscript number, but this has nothing to do with charges. This is just the number of atoms. So it's always a subscript number, sub meaning below. And again, I checked the mark scheme and I've got that right. Now, there are 2 ways that there's quite a number of ways I could write this. So long as the number of carbons, oxygens, and hydrogens are correct, that's not a problem. So the first way I've written it is how I think a student might think about it. The second way is how I know it's traditionally written by chemists. But both ways are right because there's still 1 carbon, there's still 4 hydrogens, and there's still 1 oxygen. Right, the next part says diamond has a giant covalent structure. So straight away I'm writing down it's hard, it's got a high melting point, a high boiling point. Part D, what is the number of bonds formed by each carbon atom in diamond? So I know carbon is in group 4. It needs 4 more electrons to have a stable outermost shell because it's in group 4. So it must be 4. Part E says give 2 physical properties of diamond. and I've already listed them: hard and high melting point, for example. And then it says for part F, name 2 other substances with giant covalent structures. And I just, again, memory recall, I remember graphite and I can remember silicon dioxide. So again, the total for that question is 8 marks, so it's just over 8 minutes. And so far I've been recording, including the introduction to this video, for 5 minutes and 21 seconds. So as you can see, even with me taking my time and annotating the questions and making a note of all the things that I can remember, I still am able to work well within the time permitted. Okay, so let's look at the examiner's report. Question 1A. The limitations of the ball and stick model were not well known. So many students have not revised this. So this is something that you need to make sure that you are aware of. Many answers focused upon the properties of water rather than the model itself. Okay, and that's the key thing that they're looking at, because students obviously did not know the limitations of the model. Most students were not able to write a correct molecular formula. And I think it's because they're not annotating the picture clearly and they're getting confused. There was a widespread use of superscripts. So that's numbers that are above the letters, the symbols. Word equations and presence of plus signs between the symbols. So students were getting completely confused. Students need to ensure that they use the correct notation. So you must remember to use the notation of how to write chemical equations. So the symbol has a capital letter and some symbols have a lowercase letter as well. The subscript number tells you how many atoms are immediately to the left of that number. And a full size number tells us how many molecules are immediately to the right of that number. And anything that's superscript is telling us how many charges there are. That's essentially the basic notation. And you can see I've written that at the bottom of this slide. Part E, a number of students were unable to give a physical property of diamond. So students need to really know what the properties are of giant covalent substances and metallic and ionic and so on. Part F, many responses listing examples of metals or other precious stones were seen. Buckminster fullerene was frequently given as an example of a giant covalent structure, but not given credit since the molecule only contains 60 carbon atoms. Now you have to remember, a giant structure has many, many, many thousands of atoms. So in order for you to talk about it being a giant structure, you need to think about the fact that it has to have thousands of atoms. If you think about substances like simple covalent substances like water, it's only got 3 atoms within a molecule. So it's very small, very simple, whereas giant has lots and lots. Okay, so now we move on to question 2. This question is about graphene and graphite, which I know straight away are giant covalent substances. And it says graphene is a single layer of graphite. Okay, figure 1 represents part of the structure of graphene. So it's the one layer. It says A, graphene is 1 atom thick. The diameter of the atom is 3.4 times 10 to the minus 10 meters. Then it says, what is the thickness of a graphene layer in nanometers? So nanometers, I recall, is using standard form is 10 to the minus 9. Now, because I know it's 10 to the minus 9 and the information they've given me is 10 to the minus 10, and I also know that if it's going from minus 10 to minus 9, I need to divide by 10, right? So going from minus 10 to minus 9 is a factor of 10. I need to then divide the number they've given me, 3.4, by 10, and then I get the answer of 0.34. Okay, so this is just basic maths and standard form. So if you don't remember that, you're going to have to revise that for maths anyway, so it will help you with your science. Part B, which is one use of graphene? So we've got some choices. I know it's not a detergent, even though it is slippery, and that's almost like a red herring type option. I've never heard of it used as a solvent. It's not used in polymers, so it has to be composites. And if you'd learnt the information or revised the information regarding properties of or uses of graphene, you would know this. Part C, graphene and graphite are used in electronics, right? And it's because they can conduct electricity. It says, suggest one reason why graphene is a more suitable material for use in electronics than graphite. So again, this is something that you would have been taught when you covered this topic, but you should have revised when you were reviewing it. And it's because graphene is a better, so that's the comparative word I'm using, it's a better conductor of electricity. Right, part D. Figure 2 represents part of the structure of graphite. And I can see the layers. I know that it's bonded, each carbon is bonded to 3 other carbons, and I can see that in the image. And that reminds me that there must be the 4th carbon that's delocalized, because remember, earlier on in the question, they were talking about diamond, and I remembered that diamond was in group 4. So it must have 4 electrons that it needs to bond with to have a full outer layer. So in this case, if it's 3, that means it's got 1 missing, and that's the one that's delocalized, so it can conduct electricity. And then the next part says graphite is used as a contact in electric motors because graphite can conduct electricity and is slippery. Explain why graphite has these properties. So I've got to say why. And it says you should refer to the structure and bonding of graphite in your answer. So it says each carbon atom bonds to 3 other carbons. Now, I later went back and read the question again, and it says you should refer to the structure and bonding. So I've then said each carbon atom covalently bonds to 3 other carbons. So there is 1 electron that is delocalized in every carbon atom because it is in group 4. So it has 4 electrons in its outermost shell, therefore has 1 free it should be 1 free electron to move throughout the giant structure. This makes it conduct electricity. Because of this, it forms hexagonal layers, and this means they can slide across each other, making graphite slippery and used as a lubricant. So I've given the reason why it has layers, I've given the reason why it conducts electricity, and therefore I think I've answered the question. I still feel like it was far too easy, but again, this is based on my revision of the different types of giant covalent carbon allotropes, and I have 2 revision videos on these 2 areas, one on the different types of properties of metals, ionic substances, or metallic bonded substances, ionic substances, simple covalent, giant covalent, and I've got another revision tool looking at carbon allotropes. So when I've marked this and I've looked at the mark scheme, I actually got level 2, I think, rather than level 3. So that's 4 marks instead of 6. And that's because even though I had the explanation, as you can see, I've underlined it as E1 to move throughout the giant structure, I didn't mention the fact that there were no covalent bonds between the layers, and that's why the layers could slip between each other. So I because of that, I didn't give myself a level 3. But you can see how it's not actually that much difficult to get decent set of marks for this question. Right, so let's look at the examiner's report. Part A, more than 2/5 of students could correctly convert meters into nanometers. So that's good in this multiple choice question. And obviously, even if students weren't sure, they could pick one. So they had, I think it was 1 out of 4 chance of getting it right. Part B, around 38% of students mistakenly thought that graphene could be used to produce polymers. So a large number of students, for some reason, linked graphene with polymers and not composites. Less than 1/5 of students knew the correct answer, that graphene could be used in composites. Part C, more than 1/5 of students scored a mark by saying either that graphene was stronger or a better electrical conductor. A common mistake was to not refer to the comparative properties of the materials. For example, saying that graphene is a good electrical conductor rather than being a better electrical conductor. And that was what the question was asking. Why is graphene better? Or why is graphene used, sorry. And you have to explain why. Otherwise, if they're both good electrical conductors, why use graphene? D, some students wrote a lot that was often contradictory or irrelevant. And remember, if you put a right answer and then a wrong answer for a particular response, the examiner has to give you no mark, because a right and a wrong is a wrong answer. So if you're not sure, you're asking basically the examiner to make the decision. If both your options are actually correct, so for example, like the question where I had to put down the number of atoms or write the formula for the H3OH, for example, both of my answers were correct, so I would get the mark. But if one was correct and one was wrong, I would get 0 marks for it. So you have to make your mind up what you think is the right answer. Otherwise, you're leaving up to the examiner, and the examiner can't have a right and a wrong answer. It will be wrong. So some of the examples they gave were bonding was both ionic and covalent. They can't be both. Many answers comprised a page about electric motors and the need for lubrication. Totally nothing to do with the question. It was irrelevant. How graphite was a good conductor was not well explained. And very few wrote about charge being carried or the electrons moving through the structure. The use of the word electricity was often misused, with students sometimes writing about electrons carrying electricity. And this is why all those students that I teach, I don't use that word electricity when I'm teaching the circuits topic, because I think it's confusing. Use the word current, charge, potential difference, power, resistance. Don't use the word electricity unless you're talking about electrical energy or electrostatic stores of energy. Don't talk about electricity because it's just confusing. Nearly a third of students did not attempt this question, with about 35% gaining 1 mark or more. So that's the 6-mark question. That's nearly 10% of the paper that students were not even attempting. Most marks weren't awarded for references to delocalized electrons and layers. So most people, I suspect, got 2 or 4 marks. Right, question 3. This question is about hydrogen chloride. So straight away, I've written NM for non-metal. So 2 non-metals, it must be a covalent substance, therefore the electrons are shared. So I've written that down straight away. Part A, a hydrogen atom contains 1 electron and a chlorine atom contains 17 electrons. Complete figure 1 to show a dot and cross diagram for a hydrogen chloride molecule. Show the outer electrons only. So I'm thinking about the electron configuration of hydrogen, and it's just 1. For chlorine, it's 2, 8, 7. But I'm not worried about the first shell or the second shell, just the outermost shell. So I can already put the shared dot and cross in the crossover between the hydrogen and the chlorine electron shells. And then I can fill in the rest of chlorine. And I normally pair up my electrons so that it's easy for me to count, and more importantly, easier for the examiner to count, so that I can guarantee getting the marks. Then it says hydrogen gas H2 reacts with chlorine gas to produce hydrogen chloride. So what I've done is I've just looked at that, and then I've looked at the next bit, which says complete the balanced chemical equation for the reaction between hydrogen and chlorine. So I've just drawn arrows to show where those words should appear in terms of their chemical symbols. Now, H2 they've already given me. Chlorine gas, I know chlorine's in group 7. I know chlorine goes around in pairs, so it must be Cl2, and that's a number 2, showing that the number is lower, not lowercase, subscript. So it's telling me that there are 2 chlorine atoms bonded together covalently. And if there are 2 chlorine atoms and 2 hydrogen atoms in the reactants, there must be at least 2 hydrogens and 2 chlorine atoms in the products. And they've told me the product is hydrogen chloride, and I can see how it's bonded in the diagram. So it's got 1 H and 1 chlorine in 1 molecule. So I must have 2 of those in total. So again, I've got full marks. Right, so figure 2 shows the reaction profile diagram for the reaction between hydrogen and chlorine. So I look at the diagram and I can see that the reactants have a higher energy than the products. So straight away I can see that energy must be lost to the surroundings, and therefore it must be an exothermic reaction. So I've annotated my diagram. It then says part C, what do A and B represent on figure 2? So A must be the activation energy, because I've learnt that, I've remembered that the hump is the activation energy, and B is the energy change of the reaction. And then part D, how does the reaction profile diagram show that the reaction is exothermic? Well, I've already annotated that on my graph. There is more energy in the products than more energy in the reactants than there is in the products. So therefore, energy must be lost to the surroundings. And again, when I've checked the mark scheme, I can see that I am right. And then part E, it says hydrogen chloride gas dissolves in water to form hydrochloric acid. Okay, hydrochloric acid contains hydrogen ions, so straight away I know hydrogen is H plus, and it says and chloride ions, and I know chloride ions are Cl minus 1. Explain why hydrogen chloride gas does not conduct electricity. Well, I've already said that it is a simple covalent substance, and I know they don't conduct electricity because the electrons are shared and therefore locked into the bond. They're not free to move. But hydrochloric acid is able to conduct electricity. Well, it's got ions, which are charged particles, which can move, which are free to move. So I've written HClG, so that's hydrogen chloride gas, is a covalent compound. So electrons are shared and there is no overall charge to the molecule. So there are no charges to move. Hydrochloric acid can conduct electricity because there are charged ions which are free to move and transfer current. Now, I've checked this, marked it, got the full marks. One thing I will say, I was rushing a little bit and I wrote HCl with a G, meaning that it is a gas. And then I wrote HCl and then acid. I could have written HCl AQ as in aqueous. Now that would be fine because the examiner would know what I'm talking about, but don't be tempted to make the mistake of just writing HCl in both cases, because then it's hard to differentiate what you're talking about, because they both have the same formula, HCl, but they're very different substances. So just bear that in mind. Now, looking at the examiner's report, now this question was given to both foundation and higher, so I'll go through the foundation examiner's report, then the higher. In foundation, part A, 28% of students did not attempt the question. Of those that did, the majority of students were able to draw a bonding electron pair. However, many were not able to work out or recall that chlorine had 7 electrons in its outer shell and included 17 electrons on the outer shell. Others tried to draw the inner shells and then overlapped these with the hydrogen electron shell. So that would have got no marks. 23% of students achieved full credit. So it's not that difficult. Make sure you understand how to show covalent bonds and ionic bonds using dot and cross diagrams. Part B, this question was not answered well, with 6% of students achieving 1 or 2 marks. So this was not done well at all. Most students were not able to recall that chlorine gas is a molecule with the formula Cl2, but some were, however, able to access mark point 2, which required the correct balancing of an equation with HCl given. Others, despite figure 1 showing a hydrogen chloride molecule, gave formulas such as H2Cl2 or H2Cl. Some students gave a word equation despite the instruction in the question to complete a balanced chemical equation. Part C, 5% of students achieving 1 or 2 marks. A variety of responses were seen, including amplitude and wavelength descriptions. Very few students appeared to know the term activation energy, and even less that B was the overall energy change. I think students are getting confused and just thinking about nanometers when it comes to wavelength, but it isn't. It's a measurement, okay? And part D, responses needed to be specifically linked to the reaction profile diagram rather than stating what an exothermic reaction is. 3% of students managed to obtain this mark, 3%, with many describing the pattern. For example, it goes up, then down, or talking about an energy decrease, but without a link. 27% of students did not attempt this question. Part E, 30% of students did not attempt this question. Those that did attempt the question displayed a lack of understanding of the structure of a small molecule. Many students stated that gases do not conduct electricity, but liquids do. That makes no sense. 6% of students achieved 1 mark, which was usually for stating that hydrochloric acid contains ions. A few students could also state that hydrogen chloride does not contain ions. Hardly any students refer to how these ions would enable an electric current to flow. Okay, now for the higher tier. Part A, 59% of students were able to work out or knew that chlorine had 7 electrons in its outer shell and consequently completed the diagram correctly. Others who gave an incorrect number of electrons were usually able to draw a bonding electron pair. Part B. Many students were not able to recall that chlorine gas is a molecule with the formula Cl2, but some were able to access mark point 2, which required the correct balancing of an equation with HCl given. Others, despite figure 1 showing a hydrogen chloride molecule, gave formulas such as H2Cl2 or H2Cl. Part C. This question was not well answered with a variety of responses seen from products and reactants to wavelength descriptions. Activation energy was the most common correct response, but few knew B was the overall energy change, with students often given insufficient responses about energy released or lost, with no reference to change. For this marking point, 35% of students were able to achieve full or partial credit. Part D. Responses needed to be specifically linked to the reaction profile diagram rather than stating what an exothermic reaction is. There were some responses showing that reactants were higher than products on the diagram, but few related this to energy. 20% of students achieved the mark. Part E. Generally, there was a lack of understanding of the structure of a small molecule. 8% of students achieved 2 or 3 marks. The first marking point was the lowest achieved of the 3, with answers in terms of full outer shells and also suggesting that the non-conductance was due to the gaseous state and the larger spacing of the molecules. Those who did obtain this mark usually gave hydrogen chloride not containing ions rather than the lack of an overall charge. A significant number of students gave answers for marking point 2 and 3 in terms of delocalized electrons rather than the ions, even though ions were mentioned in the stem of the question. So they gave you the clues. For the third marking point, students often said that ions were free to move, but failed to say how this facilitated conduction. So there's a lot of detail there. There's a lot of things to think about. Every year, bonding comes up at some point. It's a really popular topic because it's really fundamental to a lot of chemistry. So please, 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 I hope you found this useful. Remember to subscribe and like. Check out the sciencerevisioncoach.org website and all the other videos that will support you in preparing you for your remaining GCSE exams. Goodbye and good luck.